The topic of discussion today is Introduction to Data. It's a part of course HAP 719. So my name is Mohammed Ismail and let's get started. Today we'll be discussing about data matrices and types of variables, relationship between numerical variables, data summary and data distribution, and last we'll be discussing about population and sampling. Coming to data, it is defined as information such as facts and numbers used to analyze something or make decisions. The best examples or the common examples of the data includes individual prices of goods and services, weights, names, ages, temperatures, and distances. So data is a raw form of knowledge and on its own it does not carry any significance or purpose. Data matrix and variables. Coming to data matrix, it's basically a table or a data frame which includes both rows and columns. The rows represents an observation. It can be a case, a group, or an individual. And a column represents a variable. It can be a measurement or an indicator. Now, talking about the data variables. So data variable are of two types, a categorical data and a numerical data. Those two categories are self-explanatory. Now, talking about type of categorical data, we have nominal data and ordinal data. So nominal data in simple terms means it's a name of something, and ordinal is like order. So nominal data can include names such as International Classification of Diseases, and the ordinal data can include severity of illness, example, stages of cancer, and it also includes the gender, male or female. It can also include data which are in the form of yes or no's, one and zeros. And now coming to the numerical data, it's of two types, a discrete and continuous. So the discrete data means point data which is collected at a point, and a continuous data, it's like with changes with time. Now coming to the examples of discrete data, it includes the count of hospital patients at a particular period of time, and the continuous data includes the expenses, the RBC count or the lab values, which changes with time. The other example which can be given for the continuous data includes the recording of the values of heart rate, the blood pressure of the patient, and the changing lab values. Relationship between numerical values, often referred as correlation. It describes how two or more variables change together in datasets. Now, investigators are often interested in finding a relationship between variables. When we plot a graph for two variables, or to know the relationship between two variables, we may get the graph in one of the following ways. The first is a strong positive correlation. It shows both x and y are highly dependent on each other, or one variable may affect the influence of the other variable. Now, the example for this strong positive correlation is the age of the car and its resale value. Generally, new cars have higher resale values, resulting in strong positive correlation. Coming to an example of weak positive correlation or moderate positive correlation. So the example for this would be the amount of time spent studying on an exam and the exam score. Typically, as study time increases, exam score tends to improve, indicating a moderate positive correlation. Now, coming to an example of strong negative correlation. So it's the number of cigarettes smoked per day and the lung function. As the number of cigarettes smoked increases, lung function tends to decrease, showing a strong negative correlation. And the last would be no correlation. Now, the example for no correlation would be the size of shoe of individual and their favorite ice cream flavors. So there is likely no meaningful relation between these variables. Hence, there is no correlation. Now let's talk about data summary and data distributions. The first in this topic would be scatter plots. Scatterplot provides case-by-case view of data from two numerical variables. They are especially helpful in quickly spotting associations between variables. Now, the example you can see on this graph is the weight of product in pounds versus the price in dollars. As you can see, as the weight increases, the price of the product also increases, thereby showing a positive correlation. Dot plots and the mean. A dot plot is a one variable scatter plot. It has only single axis. Mean, sometimes called as average, is a common way to measure the center of distribution of data. The mean is the measure of central tendency, and it represents the typical or central value of a set of data points. Histograms. Histogram is a graphical representation of the distribution of a dataset. It's a way to visualize how data points are spread across different values and intervals. They are commonly used in statistics to understand the shape, the center, and the spread of dataset. Histograms are especially convenient for describing the shape of the data distribution. When data trail off the right in this way and have a longer right tail, the shape is said to be right skewed. In case of right or positive skew distribution, the mean and the median drifts away from the center of distribution. And when data set have a reverse characteristic, that is, have a long thin tail on the left, is said to be a left skewed, and the mean and the median drifts away from the center of the distribution to the left side. Data sets that show roughly equal trail in both directions are called as symmetry, and the mean is equal to median in this case. Variance and standard deviation. Here we introduce two measures of variability, the variance and the standard deviation. The variance is roughly the average squared distance from the mean. It represents the spread or dispersion of data points. It is denoted by sigma square for population and S square for sample. Coming to standard deviation, it is the square root of the variance and is roughly described how far away the typical observation is from the mean. It is denoted by sigma for population and S for sample. Plots and the median. A box plot summarizes a data set using sample statistics and extreme values. The box represents the interquartile range, which contains the middle 50% of the data. It is defined by the lower quartile Q1 or the 25th percentile and the upper quartile Q3 or the 75th percentile. The vertical line inside the box represents the median or the 50th percentile. The upper quartile is the value below which 75% of data falls, and the lower quartile is the value below which 25% of data falls. The maximum value within upper whisker is the highest data point within the defined range, often 1.5 times the IQR value above Q3. Any data points above this value are considered outliers and are plotted as individual points. The minimum value within the lower whisker is the lowest point within the defined range, often 1.5 times the IQR below Q1. Any data points below this value are also considered outliers and are plotted as individual points. The last topic of this presentation is population and sampling. Let's understand this with an example. Let's say we are conducting a study about disease, and this disease is called a disease X. It is estimated that over 1 million people are affected by this disease. To study each of the patients is extremely difficult. To get around this, we perform an experiment using a random selection of people with the disease X, and they are known as sample. The sample has less number of people compared to the population and is used to make a general conclusion about the population. The measurable quantity in a population is called a parameter, and that of a sample is called statistic. In the study, we calculated the duration of illness for disease X, and it was found to be 10 days, and it came from the sample, so it is known as a statistic. We do not know the duration of illness for the whole population, but let's imagine this value to be as 16 days, and this value is known as a parameter as it comes from the population. We observe that there is a difference between the statistic and the parameter. and this might be due to many reasons. The most common factors affecting sampling are the selection bias and sampling error. The selection bias occurs when participants in the sample are not equally balanced or objectively represented, and the sampling error occurs when the sample does not include all members of the population. Now let's begin with the assignment part. To begin with the assignment, we need to first download datasets from the website on openonlinecourses.com. In this, we go to 719, and in that we go to the introduction to data, and there you can find below the assignment section in which you have all the questions for which we have to find the answers. And now we have to click on the download data to download the dataset. Now let's extract the data. Once you finish extracting the data, copy datasets into document section so that way you can easily access the data in the R Studio. Now after finishing this, let's open the R, and this is the user interface of R. So we require two libraries which are not installed. So for that we use the code install packages, and in that we need ggplot2. Write the name there and click enter. It will initiate the installation process for that. And after that we also need to install package named readr, which will be helpful in reading the CSV file. Now once you have downloaded the packages, now it's ready to use. Let's begin with the question 1. So the following question, uh, we first need to load the packages. So we use the code library readr and library ggplot2. Select both the code lines and hit run. So now both the libraries are ready to use. Next thing is we load the data using this syntax. We load the data in this variable df. Now you can see that the data which we have already downloaded and saved in the document section appears here in this right side corner. Next, we need to load the data by using this syntax. Before we start the data analysis, we need to first look at the variables which are present in the data. For that, we can open the dictionary which is provided in the assignment part. When you open the dictionary file, you're going to see all the variables which are present in the data and also the description of the data. So for the first question, we'll be using the neoplasms and the endocrine, that is BS2LR and BS3LR. Now let's begin with the analysis part. Now for the first question, we are gonna need to drop the ID variable, which is mentioned in the data description here. Drop this variable, and the second part which we are gonna do is drop all the variables where data are missing. For this, we are gonna use this syntax, and we are gonna replace all the missing values with 0 with this syntax. Now, the third part of this question is to plot a graph for the progression of illness in neoplastic systems against the endocrine systems. For that, we are filtering the data sets and selecting only two variables. For that, we are creating a new data frame by name filtered underscore df, and we are selecting a data frame that is ds2lr, which is a neoplasm, and d data frame bs3lr, which is endocrine. Now we are making sure that these values are not below 0. Now, for plotting a graph, as data set is very huge, we are using only the 10% of the data. So for that, we are creating another data frame, which is under by the name sample size, and using only 10% of the data. Now to generate a scatter plot, we use the following code. We are saving the output graph in this variable p, and we are using a library ggplot, which we previously imported. Now the df sample indicates the file name or the data frame which we are going to use to create a scatter plot, and we are assigning x-axis with bs2lr, which is the neoplasm, and bs3lr, which is endocrine. Now the geom point indicates we want a scatter plot, and the geom smooth with the method lm indicates we want a linear regression line. BSE equal to false indicates we don't want to shade the area around the regression line with the confidence interval. So it just give a simple line. And we can also change the color. So currently we have placed it as color blue. And we have also given labels by using this code labs. On the x-axis, we are we have named it as progression in neoplasms. And on the y-axis, we have named as progression in the endocrine, metabolic, and immunity. And the title we have mentioned as a scatter plot of progression in neoplasms versus endocrine systems. Now the theme minimal indicates that we want a simple graph, we don't want too many colors, and we want to keep it as simple as possible. Then we print the graph. So now we select the whole equation and just click run. It might take some time to plot the graph as dataset is too huge, and we need to wait for a few seconds before the plot appears on the right side. Now coming to the second question or the second prompt, the second prompt asks to calculate a histogram for progression in mental disorders and to repeat the histogram, and this time use a natural log for progression in mental disorders. Now for this we use the same methods as we used in the first question, that is first load the library, read the file, drop the null values, clear all the missing data and replace the missing values with 0. Then comes the part of plotting a histogram. The first question was to plot a histogram for the progression of mental disorders. For this, again, we use a ggplot library and we save the graph uh, in the variable p. Now, let's decode this syntax. So the ggplot again says the library which you are going to use. The df is the data frame which you are using. The bs5lr is a variable which has data for the mental about the progression of mental disorders, and here we are setting the x value for only the single variable, that is BS5LR, that is for mental disorders. Now we are giving instructions to the code that how we want a graph. So we want a histogram, which says we want a histogram. The bin width 2, the bin width 2 specifies the width of the bins or the width of the each histogram, and fill is the color which you want to be filled in the bars, and the color black indicates the border line, and the alpha 7 indicates the transparency of the bars. And we again label by using labs. We label the x-axis with progression of mental disorders and y-axis the frequency, and we give a title, uh, namely histogram of progression of mental disorders, and we keep the theme again as minimal. Then we print the file. So let's select this part and run the code. Again, you can see the histogram is plotted. The width is 0.2, the color field is blue, and the border we got is black, and the transparency is set to 0.7%. We got the x-axis as progression of mental disorders, y-axis as frequency, and title as histogram of progression of mental disorders. Second part of this question is to plot a natural log of progression for mental disorders. For this, we use the same syntax as we used above, but here we change the x-axis as log because we want the log of progress. So we change it to x equal to the log of BS5LR, and the rest remains the same. The x-axis also changes. We can change the x-axis to uh, as natural logarithm of progression of mental disorders. So now again we select the equation and run. Now this time we get a different graph as we have plotted it for the logarithmic values. You can see the log values on the y-axis, and this is the graph which comes as an output. Now coming to the third question, which says to calculate the correlation matrix between any pair of variables and also to show the scatter plots of all pairs. For this again we load the libraries, that is readr and ggplot to read the file, drop the id columns, drop the variables with where all data are missing, and replace the missing values with zeros. Now for this question, we are selecting BS4LR and BS6LR. BS4LR is for the blood systems and BS6LR is for the nervous system. So now we are gonna first filter the data and save it in the data frame filter df, and we are gonna create uh, a subset in which both BS4LR and BS6LR are equal to 0 or not below it. Next, we are going to use the function of COR, which is for correlation, and we are going to save this value in a correlation BS4LR and BS6LR. We can name the variable as per our choice. And so in this, we have selected the from the data frame filter DX, we have selected the variable BS4LR on one axis or as one variable, and the second we have selected again that from the filter data we have selected BS6LR, and we use the condition complete.obs. Now this condition complete.obs, it specifies that only complete cases, rows with non-missing values for both variables are only considered. Next part is to print the value. So for that we use print, then we use paste command, in that we give a variable or a line which says correlation between BS4LR, BS6LR, and we then add the value which we have calculated in this above from this above code. The next part will be to create a scatter plot. The scatter plot is as similar to that of the first question. So we just select the whole equation or the whole code and enter run. Now you can see the data frame is loaded. Uh, so here we can see that we got the correlation value between BS4 LR and BS6 LR. That is minus 0.2459, which shows a negative correlation between both of them. Now again for the graph, as the data size or data set is big, it might take a few seconds to show up. So this is the scatter plot which we gets after it loads for a few seconds. Now coming to the last question, which says to calculate the summary of the data that includes mean and standard deviation of each variable and identify the variable with the largest mean and identify the variable with the largest standard deviation. So for this, again, we load the libraries, read the data, remove the ID column, remove the variables with all missing data, and replace the missing values with zeros. Now, uh, for calculating the mean and median, we only need a numeric values. For that, we use or we save only the numerical variables in this data frame as numeric underscore vars. We use this condition is numeric to select only the numerical variables. Now to calculate the summary of the data for the numeric columns, we save the generated results in this data frame, that is summary underscore df, and we select mean and the standard deviations. Now converting that summary into a data frame, we use the function data dot frame and convert the summary data frame into a convert the summary into a data frame. Now we print the data frame, and the last things will be finding a largest variable. For that, we'll use a code uh, in which we specify the, the maximum value for summary df, and one indicates mean here. So next thing is we print the largest mean value, and the last part will be to find the variable with the highest or the largest standard deviation. We save that value in this variable largest standard deviation variable, and in this we select or we write a code like names summary df, which we generated here above, and in this we use the code which dot max summary dot df, and this too is for the standard deviation, and we print the largest value by using this code. Now we select everything and we just hit run. It takes some time to generate the results, and yeah, you can see here it says the variable with the largest mean is uh, bs16lr, and so first we see the summary data frame which gives uh, the mean and standard deviation for each variable, that is for dm bs1lr bs2lr, for all the variables which are with the numeric values. Next was printing the variable with the largest mean, and that is the bs16lr, and the last one is to print the variable with the largest standard deviation, and that comes out to be the bs16lr. These values you can copy and directly paste in the Word or PowerPoint. You can also copy this image directly from here and paste it in the Word document or PowerPoint, in which form you want to save or submit your assignments. So that would be it for the assignment. Thank you so much.